Next topic, Excenter. So what is excenter of a triangle? This is a triangle ABC. This is a triangle ABC. Extend the sides AB, AC. And these two are exterior angles, exterior angle of B and this is exterior angle of C. Draw angular bisectors of these two exterior angles and also draw internal angular bisector of A. So all these three meet at a point. This point is called excenter, denoted by I1. Why it is called excenter? Already you know what is angular bisector. Every point on this equidistant from these two, every point on this equidistant from these two, every point on this equidistant from these two lines. And this point is equidistant from these three lines. Therefore, if you draw a circle, the circle touch all the three sides of a triangle externally. And this is called X circle. And this point is called excenter. And radius of the circle, if you draw a perpendicular, this is called the radius of the circle. So x radius r1 is equal to, the formula is delta by s minus a. The radius of x circle opposite to capital A is delta by s minus a, where A is the side opposite to capital A, and S is a semi-perimeter and delta is area of the triangle. If you know area of the triangle, semi-perimeter and small a, then R1 is equal to delta by S minus a. Similarly, what is R2? X radius opposite to vertex B, delta by S minus B. R3 is equal to delta by S minus C. So this is about excenter. Next, if this is a triangle ABC, draw external angular bisector of B and external angular bisector of C. Already you know this is intersect at excenter I1. Then what is angle BI1C? What is this angle? So I want to give a simple proof. What is sum of all these three angles, which is equal to 180 degrees? Sum of interior angles of a triangle is equal to 180 degrees. A by 2 plus B by 2 plus C by 2 is equal to 90 degrees. Okay, this is 1. Then what is this angle? This total angle is 180 minus B. Half of this angle is 90 minus B by 2. This total angle is 180 minus C. Half of this angle is nothing but 90 minus C by 2. Let this be theta. The sum of these three angles also equal to 180 degrees. That is theta plus 90 minus B by 2 plus 90 minus C by 2 is equal to 180 degrees. 180, 90, 90 cancel. So what is theta? Theta is equal to B by 2 plus C by 2. But what is B by 2 plus C by 2? Nothing but 90 minus A by 2. So therefore, angle BI1C is equal to 90 minus A by 2. Angle at excenter is 90 minus A by 2. Angle at incenter is 90 plus A by 2. Okay. So this is the way of finding this one. Next point. This is a triangle ABC. The two sides AB and AC are extended. Draw external angular bisector of B and internal angular bisector of A. They also meet at I1. Then what is this angle? What is angle BI1A? Here angle BI1A is half of the third angle C, nothing but C by 2. How to prove this? Here already you know sum of the three angles A plus B plus C is equal to 180 degrees. A by 2 plus B by 2 plus C by 2 is equal to 90 degrees. Here this total angle is A, half of this angle is A by 2. This angle is B. And what is this part of the angle? This is nothing but 90 minus B by 2, and let this be theta. Sum of these three angles in this triangle BI1A is equal to 180 degrees, that is A by 2 plus B plus 90 minus B by 2 plus theta is equal to 180 degrees. This is equal to A by 2 plus B minus B by 2 is B by 2 plus theta is equal to 180 minus 90 is 90. What is A by 2 plus B by 2? This is nothing but 90 minus C by 2. So 90 minus C by 2 plus theta is equal to 90 degrees. Therefore theta is equal to 90 cancel, which is equal to C by 2. So this angle is C by 2. Angle BI1A is equal to half of the third angle. Similarly, if you draw angular bisector of C, external angular bisector of C, it also meet at I1, then what is this angle? This is nothing but half of this angle, nothing but B by 2. This is C by 2. So total angle is nothing but B by 2 plus C by 2, which is equal to 90 minus A by 2. So this is about angles at excenter. Next, this is a triangle ABC. Draw an altitude from A. Draw one more altitude from B. These are the two altitudes. The point of intersection is nothing but orthocenter O. The point of intersection of altitudes is O. This is the midpoint of BC. Join AD. This is the midpoint of AC. Join this also. BEAD. These are the medians, and this point is nothing but the centroid. Point of intersection of medians is called a centroid. At the midpoint, if you draw a perpendicular line, at this point also if you draw a perpendicular line, they meet at this point. This is perpendicular line, this is also a perpendicular line. This is called circumcenter, denoted by S. Point of intersection of perpendicular bisectors is nothing but circumcenter. Here point of intersection of altitudes is orthocenter, point of intersection of medians is centroid, and point of intersection of perpendicular bisectors of sides is circumcenter. And all these 3 points always on a straight line. These 3 points always on a straight line. These 3 are collinear, and this line is called Euler's line. So therefore O, G, S are collinear. And very, very important point here is centroid divides OS bar in the ratio 2:1. Centroid divide the line segment joining orthocenter and circumcenter in the ratio 2:1. That is, If this is orthocenter, this is centroid, and this is circumcenter, OG is to GS is always equal to 2:1. How to prove this? Actually, proof will be after one more class, that is similar triangles. If you know similar triangles concept, of proof will be very easy. OG is to GS is equal to 2:1. In the case of isosceles triangle, if these two sides are equal, if two sides are equal, if you draw angular bisector, it is passing through the midpoint of opposite side and it is perpendicular to the base. That means this is the angular bisector, the same is median, same is altitude, same is perpendicular bisector. If you draw altitude from B, this point is nothing but orthocenter. This is the midpoint of the side AC, join these two, this is the centroid, point of intersection of medians. And at the midpoint, if you draw a perpendicular line, it meets at this point, so this is circumcenter. In this case also, OGS are collinear and G divides OS in the ratio 2:1. 2:1 internally. It is always internal, please. And if you draw angular bisector of B, for example like this, the point of intersection of angular bisectors is in center, so this is also in center. So O, G, S and also I on the same line. So in the case of isosceles triangle, O, G, S, I are collinear. If this is equilateral triangle, if all sides are equal, all medians and all altitudes, everything, every line coincide. If this is a median, the same is altitude, same is perpendicular bisector, same is angular bisector. Similarly, if these two sides are equal, this acts as a median, altitude, angular bisector, everything. So they are concurrent. Here this is O, this is G, this is S, this is I. In the case of equilateral triangle, if all sides are equal, that's why O, G, S, I coincide. In isosceles triangle, O, G, S are collinear and G divides OS in the ratio 2:1 internally. In the case of isosceles triangle, O, G, S, I are collinear. In the case of equilateral triangle, O, G, S, I coincide. If O, G, S, I coincide, already you know G divides the median in the ratio 2:1 internally. So this part and this part are in the ratio 2:1. Similarly, O also divide in the same ratio, S also divide in the same ratio, I also divide in the same ratio in the case of equilateral triangle. So one question given in the previous type 2 examination based on this. Here, if G divides AD, this median in the ratio 2:1, S also divide in the same ratio. So consider this as S. If this is S, this distance is nothing but capital R. Already you know R is equal to A by root 3. If each side is equal to A, capital R is equal to A by root 3. And if you consider this as in center, if you draw perpendicular to side, then this is nothing but the in radius. So if this is a circumradius and this is in radius is 1 parts out of 3 parts. This is a by 2 root 3. Capital R is to small r is always equal to 2:1 in the case of a equilateral triangle. Circumradius is to in radius in the case of equilateral triangle is equal to 2:1. This is also a previous question, please. And what is capital R plus small r in the case of capital R plus small r in the case of equilateral triangle? This is nothing but the height of equilateral triangle. Capital R plus small r is equal to height of equilateral triangle. Okay.